Hi, I want to welcome you in my talk. We will be talking about interactive development of web applications. And basically there are several main goals in this talk. So one of them is to introduce you Clojure, which is an amazing language I'm using for the last 5 years. Another is to show you why data is good, why it's good to program using data structures, and why they make basically everything much more transparent and understandable. And the last thing, which is the title of this talk, I want to show you that actually coding programming can be much more interactive than we are used to in other languages and environments. So we'll be doing some live coding, and we will see instant feedback as we will basically build a small web application. My goal in the end of this talk is to build a tic-tac-toe game, 3x3, which runs inside the browser. So we will have basically, there will be no computer AI, it will be just for 2 players, but be able to play the game and experience coding of it. Okay, so my name is Pavel Klavík. Let me first say something about me. So currently for last 4.5 years, I'm working on my own startup together with 2 other guys in this room. This startup is called OrgPad, and I'm in charge of all the technical stuff as CTO. So I did large part. I wrote large part of code of OrgPad, and actually you can see OrgPad right now. This presentation is running inside browser. It's a web application, and this is showing the presentation feature of OrgPad. But there is a lot of other stuff also. And for me, it was an amazing experience. It was actually the first web application I ever built. And I learned a lot on the way. Beforehand, I studied my PhD. I did 10 years of my study here in Prague at Charles University. And my PhD was about networks, graphs, and visualization. So it nicely fits together with the idea of OrgPad, because this is basically a network. It's a digital whiteboard. You can basically put stuff inside, and then you can connect it in any way, and you can play with the visualization and make your ideas much more understandable this way. So yeah, I'm connecting stuff from my PhD, and also during my studies I did a lot of teaching, which was great. Since I could experiment with these ideas, and I was doing a lot of stuff with students. And after I finished my PhD, I moved to Zurich. For 1.5 years, I was working at Google on their search. We're building a knowledge graph in Google. And it was a great experience, and it's also a great place to make a lot of savings quickly. So when I left Google, I was able to bootstrap my work on OrgPad completely from savings. So this was great altogether. So let's talk about Clojure. By the way, if you want to access this talk later, you can just use this link here, and you will be able to get to this presentation. And also we are recording it here, so you will be able to access the entire presentation on YouTube later. So Clojure is a relatively new programming language, but it's also not so new. It's I think 15 years now, and it was created by Hickey, who was basically an experienced system programmer who over years got really tired of these classical languages and the problems which came with them, and decided, like, okay, if I'm supposed to do coding anymore. I will have to build my own language where I can basically put the good functional programming ideas together, but make it deployable to the real production environment. Because he was experimenting with Lisp, and basically the problem was that he developed some system in Lisp and it was great, but then the company forced him to rewrite it to something else because they didn't know how to run it in production.
So Clojure is open source, right? It's a tiny code, just like Orange in the Linux. In the beginning, Linux has a tiny code, right?
Yeah, I mean, Clojure is really tiny, and it's developed rather slowly and extremely conservatively, but it can be extended using libraries in any way. So really, like the language is you can do pretty much anything, and it's nicely stable. So yeah, I don't really want to go into this picture that much, but this is from some talk by Hickey, which basically showcases the main big problems in computer science. He tried to tackle things like concurrency is really difficult in the classical languages, and there is some other stuff. So yeah, we will see. So Clojure is nowadays used by hundreds of companies. I just mentioned a few of them. Maybe we should add to this list also Nubank, which is a Brazilian banking startup, really a large company. They had IPO in, I think the valuation was about 45 billion US dollars. And their bank is built fully on Clojure, using the Clojure database called Datomic, which was also developed by Hickey. And so there is this quote by the senior architect in Walmart, which is using Clojure on their backend to do a lot of stuff. And he basically describes nicely summarize the quality that like Clojure allows one to move much faster, to produce better quality results with a smaller code base. Like the estimates are maybe 1/5 or 1/10 of the size of equivalent code base in Java, C#, JavaScript, whatever one uses. And also, because the way how code is written in Clojure, it's much more separated in the way that change in one part of the code base should not change that much other things. And so it's great. By the way, OrgPad is also one of the companies which is built on Clojure. So what you see is now is fully built in Clojure. The front-end side is running in, this is running in the browser, is built in Clojure. And the backend is also built in Clojure. So we can leverage this power quite nicely. Concerning code size, we have something of order 100,000 lines. So if we would use these industry estimates, that this would be actually quite large code base, because the corresponding size in JavaScript would be maybe order of 500,000 to 1 million. This is a huge project. And we were able to build it completely in a small team of programmers. I think we have about 2 or 3 people working on OrgPad full time. So it's amazing how fast we can move forward, and basically all the things I will be showing you today with the interactive programming it is possible to use it everywhere while working on a large code base like OrgPad. So it's not just for some toy examples. Yeah, by the way, yeah, this talk is available on this address. So you don't have to write down anything. You can just access it later. Yeah, so Clojure is a Lisp. Have you ever seen Lisp? Lisp. Is this programming language? So Lisp is actually extremely old programming language, which basically never dies and is always like resurrected and used. It it's the second oldest programming language from year 58. So the first one is Fortran, I think 2 years before that, and it was created basically from a different side. It came from mathematics. So Fortran was a language which, so first there was assembler, which basically are like the detailed instruction for the processor what it should do. So when you code in assembler, you basically describe precisely what should happen on the processor, and you have to know precisely the architecture of stuff and everything. And all these languages like Fortran and C after that were basically making it more understandable, but we're still coming from this assembler side of things. So you have some higher level constructs a little bit, but it's really still really close to what is the machine doing. And LISP came from the other side. Originally, it was not a programming language. It was invented as a mathematical notation how to write computation. So, and then one student of the guy who invented it came with the idea, okay, but we could actually make this a programming language. So he built it. And originally computers were really slow, so running LISP was costly. It was a great programming language for experimenting and building large systems, but it was too slow. It was impractical. But it came with a lot of great ideas. For instance, garbage collection, which is now used in most languages, most environments. Originally was invented in LISP, and there are other things. And I think basically it was ahead of its time, but nowadays we have powerful computers and we can actually leverage the full power of LISP. And so if you want to learn LISP, it's really easy. I mean, this is the type of notation you might know. If you want to call some function, you have the function name and then you have the bracket, and then the parameters are separated by commas. This is what you have seen probably. So in LISP, the only change is that you take this bracket here and you move it in front of the function. So you have a bracket, and the first thing here is what is the function, and the rest of the stuff are the input parameters. And usually we don't separate them by commas, we just put spaces there. So commas in Clojure are just white space. You can add them, but we don't do that. So there is a lot of advantage doing this, which is not completely clear to beginners, and I don't think it matters that much. But basically, it makes the code much more regular and nicely behaving. There is much less syntax, and so it's much easier to parse the code and generate the code and do code transformations. So in a lot of programming languages, we have something called macros, which allow you to take some code and modify it and build a different code out of it. But macros are usually really bad, that it's really difficult to build anything good with macros and make them understandable. In LISP, it's much easier, because macros and basically the structure, the tree structure of the program is immediately visible, understandable, and you can play around it. So there are some advantages, but I wouldn't dwell that much on them. Okay, let's see some example code. So this is the famous FizzBuzz. So this is actually an interactive window. I can write code here, and I will see the output immediately. So the problem is that you're supposed to print numbers, 1 up to 100, say. But if the number is divisible by 3, you print buzz, and if it's divisible, if it's divisible by 5, you print fizz. Maybe swap that. It should be the opposite way, but it doesn't matter. Yeah. So how does this work? So we have range here. So what range does is it generates a sequence of 10 numbers, say starting from 0, or if I put the starting number also, it will start from 1. So range from 1 to 100 are all the inputs, and So do sig here runs for all the values I inside of this range. So I is basically sort of like a for cycle, you know, in other programming languages. So I becomes 0, it becomes 1, okay, and then it goes inside. And inside there's this cont function, and cont is basically something like if, then, else, if, else, if. You have so you have a lot of branches, and so it works that okay, it will first check this condition whether the number is divisible by 15. If it's divisible by 15, it will print FizzBuzz, and that's it. Otherwise, it will check here whether the number is divisible by 5, and if it's divisible by 5, it will print Fizz. Now, if it's divisible by 3, it will print Buzz, and otherwise, it will just print the number itself. So you can basically build a program like this using these data structures. And yeah, now you might be thinking, if you know a little bit of programming, that okay, there may be a lot of parentheses, and a lot of people come with this understanding of Lisp and they never learn anything else. I would actually argue that there are not more parentheses than in other languages. Also, it doesn't matter that much. It's just something which looks unfamiliar, but after some time, after you spend some time coding Lisp, it's actually become quite natural, and you don't really see the parentheses. You just see the structure of the code, like what's inside what, and you learn to read it really quickly. But if I look at this example, this is some functional JavaScript, and you can see that there is similar number of parentheses here and here. But I would also argue that the version on bottom is much more understandable. There is way less of noise. So we have a lot of here stuff like these symbols, and this behaves differently, and what is the order, how the operator is applied, and I still prefer to do this, that like filter odd numbers. Map increase, inc is adding +1, and so on. Reduce plus is sum everything together. So when you learn this, it's actually quite nice. And also the code is much more concise and powerful. Does it make sense? Sure. Okay. So there are actually a few documents in OrgPad. So this one is something I built a few years ago. It summarizes the Clojure programming language. There is a lot of embedded videos and further materials. So if you're interested, you can check it out. The other one is called Interactive Clojure Tutorial. It's basically using these windows, these interactive windows. So you can just go through this interactive Clojure tutorial, maybe in 1 or 2 hours, and basically get to know the language a little bit. And you don't have to install anything on your computer to do this. So it's a really powerful way how to get the first experience, and if you like it, then you can install Clojure on your computer and get some real environment running and start some coding. Yeah. Okay, so let's do a demo. Let's start coding a little bit. Okay, so here I have my IDE. So this is actually running inside IntelliJ, and there is a plugin for Clojure, which basically adds it to IntelliJ, and you can use it all the IntelliJ powers, but on your Clojure code base. So I have two things. So this is some code in Clojure, and then I have this window here. This is called REPL. Okay, so let's concentrate on the REPL. REPL is one of the magical things in Clojure or in Lisps in general. This is basically sort of like a console where I can write some code, and I will see the output immediately. So you might know REPL from some other programming languages, maybe from Python, but this is way more powerful because this REPL is actually connected inside of a real running program. And I can examine the state of the program, or I can actually modify the code while the program is running. And this is one way of doing interactive development. That basically you have, say, your server, which is running some big application, and you connect inside of this server, and you can modify the code, and you can experiment with stuff, and you can play around. Yeah, so let's do some Clojure. So we have, let's start with data. So the data literals are, so let's say I will write some number here, send it, and numbers are evaluated to themselves. Similarly, I have strings. Strings are also evaluated to themselves. There are a few others. So there is nil, which is basically null in other languages. So this is a pointer to nothing or nil value. Usually it means that something is missing or output is nothing. There are also booleans, like this. And we have a few other things. One important type for this talk is something called keyword. And keywords are basically identifiers which describe themselves. So there's sort of like, if you know, for instance, enums, you define some constant inside of your code, and you can use these constants instead of specific values. Sort of, in a lot of situations, you can replace them with keywords. But usually, in a lot of situations, keywords are keys in hash maps. So they basically describe themselves. It's not like a string. It's basically a unique identifier. And you can also namespace them. So let's do mytalks/hello, and this allows me to ensure uniqueness of my keywords. So when I'm using, so in OrgPad, for instance, we use these keywords which are sort of unique across the entire project. So when I have some document which is called org-page in OrgPad, then the ID of this document is this org-page/ID, and this is the identifier for the org-page ID. This is the keyword, and I can, for instance, use IntelliJ and search all the occurrences of this thing, and I will see where org-page ID is used. So it's quite powerful, and also it's really fast. That keyword comparison under the hood is just pointer comparison. So there is some basically dictionary of all the keywords which are used, and when you use a new keyword, it just gets mapped inside of this dictionary. So you can do comparison in constant time, compared to if you would be using strings for it, for instance. So okay, so these are the basic types, and then you can also do composite types. So one of them is list, which is the round brackets. So 1, 2, 3. If I will code this, I will get an error because actually when I'm using list, it means a function call basically, and it's complaining that 1 is not a function. It's a Java long, and yeah, I can't call it as a function. But I can do this, add this quote here, and now it's just a list. There's this quote function or quote special form, which basically will just not execute it. It will just return me the physical list. But lists are usually not that much used while coding Clojure. So instead, we normally use vectors, which is in the square brackets. So I have 1, 2, 3. like this. This is a vector. So vector, or maybe you know it under the name array, is a data structure where you have some order of the elements, and you can basically access any of them. So let's say I want the second, which is like this. So it's indexed from 0. So the 0th element is 1, and so on. So so vectors are good if I want to random access any index, or if I want to append at the end. But if I want to add stuff in the middle, it's rather slow. And then the other data structure is a hash map. Hash map is written in the curly brackets, and so hash maps are mappings basically. So you have some keys and you have the corresponding values. And what you can do quickly with a hash map is to look up what is the value of a key. So suppose that I have my hash map like this. Yeah, and also you can arbitrarily nest things inside. So, and mix data types. So I can have a hash map having these 3 keys, but also keys can be anything. So I can have like 1, 2 is like this. So I can mix stuff up, and they're these pairs. It is possible to add commas here, but usually we just ignore this and format it like this, and it's quite understandable what is the mapping. Okay, so this is a hash map, again evaluated to itself. If I want to get a value here, I can use the function get, and let's say I want to look inside what is A. I get 1, 2, 3, and this is a quick lookup. Yeah, another thing is that, okay, suppose that I store it, I name it under symbol M. So right now when I use M, I will just get the hash map I stored. Sure, I can go M, say 1, 2, I get the value hello. Okay, suppose that we want to change it now. We want to add something inside of this map, say, or override something which already exists. Then there is the function assoc. Assoc takes a map, takes the key, and takes a value. So suppose that we do D is XYZ. And I get a new map which has D appended inside. But what is actually happening under hood, that the original map is preserved. So, and this is something which is quite uncommon in programming, that the changes don't modify the original data. So there is this is something called immutability, that you have your data structures and they cannot be changed from outside. So you have some value, and if you hold the value, no one can override the value under you. So, but you can basically generate a new value, and you can imagine that what it does, it copies the value on the site and then modifies it. But of course, it doesn't happen this way because it would be too slow. So there is a clever trick which allows one to do this quickly. Okay, so. There are also hash sets. So this is sort of like just keys in a map. So I have basically I have a hash set like this, and I can ask, okay, is there the value, say, B? I will get true. Is there value X? I will get false. So it's and I can add things into it or remove. So say conch X, and it will expand the set. So, and these data structures are basically everything you need if you want to build your program. So, and you can nest them and expand them like this, and yeah. So let's take a look at some example of real data. So I have built this example document running inside OrgPad. There are just two nodes connected. One node is an image, another has a title. So I can, what I can do is I can connect REPL inside of this browser window, and I can look at what is the state of the system. Okay, so I just go here. I will connect inside the browser. So right now I'm communicating with my browser window. Yeah, I can, for instance, do this. And as you can see, it runs a JavaScript function inside the browser window. So it's connected. And usually when I am doing programming in my office, I have a large screen where I run the IDE, I run the REPL, and I run the window, and I can basically see everything at the same time. This is not something we can do here so easily. But okay, so if I want to look at the entire state of the application, I can just play it here. Okay, it says it's too big. So let's just print the state of the document. That should be very. Oh, let's just print the all the nodes. We call them units in the code, and I get this. So this is this data basically fully describe what is appearing on the screen. So this is a hash map, which has as keys are IDs of units. So basically I want to sort of store all the units and have random access to them. If I want to check what is inside of some unit, I can just get inside of this map and see. Okay, so let's print what's inside. We don't need the keys. Okay, so each unit is a nested hash map, like this. Let's see what is simple. Yeah, there's this unit with the title example cell here. So, and you have these keywords, which are the identifiers, and it sort of corresponds to, like, if you have an object, it has some fields. So each key you can think of as a field here. It has a name and it has some value. So this cell, for instance, has a position. Yeah, let me just copy this ID here. And these are 128 random bit integers, basically unique identifiers, which you can generate by random, and they are ensured to be unique mathematically. Okay, so I have this. Okay, suppose that I move my cell. Yeah, you can see that the position is changed now. If I move it again, now you can see it's updating real time. So, for instance, when I do some coding and I want to look inside the state to see what's going on, I can just quickly print it here, like this. And if I go and change the color of this cell, and I run it again, you can see that here in properties there is the color blueberry. So changes are immediately reflected. So normally what we do is that we model data in Clojure as maps or nested maps in this example. So there is the main map, which describes the unit properties. There is then one nested map, which describes what are the properties like title size and color. There are also some vectors, which shows what's visible and so on. So you have stuff like this, and then you have maybe some other stuff here. It doesn't. The details don't really matter. But what I like about this is that the data is immediately understandable. It's quite transparent. There is nothing hiding inside of the unit. It's not some hidden package which has a lot of code packed inside. There is nothing more than just this piece of data. You can examine it. You can play with it. You can print it here, for instance. You can send it over wire. Someone else can read it, and so on. So the data is very powerful. And then one can think of the entire code as basically having the data and then doing data transformations. So you take your data and you modify it into something else, and then you modify it again, and so on. And yeah, so this is I think the core idea. So there is a lot of basic functions. I think the core is a few hundred functions in Clojure, which is not so bad. It's much smaller than the other languages I know, and there is a lot of regularity in how Clojure works. So, for instance, suppose that we want to do some arithmetic. Adding numbers, multiplying, so on. So adding numbers is just a function. It works exactly the same as everything we have seen before. So suppose I want to add 1 plus 1. At the first position, there is the plus function. Always starts like this. So it's plus 1 and 1. Yeah, it's a little bit unusual to use this prefix. This is called prefix notation, but one gets used to it quite quickly, and it doesn't matter that much. And there are some advantages of that. For instance, there is a big table of priority of operators. If you use any other language, like you probably know this from your elementary school, that if you have adding and multiplication, summation and multiplication, first you have to do multiplication, and after that you have to do addition. And there is a lot of popular math quizzes like this, like there is a picture like 5 plus 3 times 2. What is the result? A lot of people like.
It's concise.
Yeah. I mean, this is clear. I have always the bracket, so I always know what it is. Of course, in math notation, basically the reason why multiplication is before addition is that it appears more frequently, like things like polynomials. So it makes sense to have this convention. But if you do programming, then you have 50 operators, and then you have the precedence, and no one remembers it, and there are some silly mistakes like that. So, like ternary operation in C or C++, it's like a nested ternary operation. Like no one knows what is the precedence, so you end up writing brackets anyway. And there is a lot of extra stuff. For instance, right now I have 2 numbers which I'm summing, but why should I use 2 numbers? I can actually sum 0 numbers. The answer is 0. I can sum 1 number. The answer is 4. I can sum 1, 2, 3, 4, 5, 6. The answer is 21. So the advantage of this approach is that it takes arbitrary number of inputs. Yeah, similarly, comparison. I can also use as many numbers as I want. So this will check that 1 is smaller than 2, and 2 is smaller than 3, and 3 is smaller than 4. In a lot of situations, this can make this stuff much more understandable. Yeah, there is, of course, multiplication. Yeah, division. Division is actually in Clojure using exact ratios. So these values are exact. You can convert them to a floating point number, but you don't have to. This is something added in Clojure. And yeah, or you can just do like directly, like write a float like this. Okay, so these are this is the arithmetic. Yeah, if we want to do branches, first we have to talk about conditions. So in Clojure, the way how it works is that almost everything is true. Every value is truthy. There are only two exceptions: what is false, and that's the false itself, and that's nil. So if I have a comparison like this, say 0 is 0, then no or yes, otherwise no, it will output me yes. So if works that there is the test, there is some expression which evaluates to something. If the value is false or nil, then it will go to the else branch here, and otherwise it will go to yes. Yeah, so for instance, if I have hello here, this is not nil or false, it will go to yes. But if I have nil here, I will go to no. So it's quite simple convention, and usually in code we use nil as sort of nothing, and we do like when, for instance, I know there is this thing called nil pruning, where when the input is invalid, you might just silent the output nil and do nothing. And it's nice that you can compose these things together, and you don't have to have some null pointer exception. You can just, okay, nil, let's go on. Let's skip that. Yeah, there is this cont form you have seen. So there is the test. Okay, let's do x is 4. Okay, cont if x is 2, then print x is 2. Otherwise, if x is smaller than 3, x is less 3, and else x is at least 3. Yeah. Okay, let's do like this. And you can. So this else thing, it's just a random truthy value, and usually in Clojure we just put else keyword here. So it's like more understandable what's happening. But I could have there anything. I could have like 42, and it would still work the same. Now 42 is truthy, so but it's sort of like the default like catch-all is like in code you have else, and you look at it and you immediately see what's going on. Okay, so these are branches. Now suppose that we want to do variable assignment. So there is no variable assignment. You can't do that. Or we usually don't do that. And the point is that variable assignment is not so great idea, because you have something which you have some name which is changing what the value is, and you don't have a good control over it. So if you have, for instance, the situation is that if you have a lot of threads, so the computers nowadays, they're capable to do a lot of computations at the same time. And there are difficulties coming from that, because if you do a lot of computations at the same time, you easily can get to a problem where two processes are trying to access some shared memory, and maybe one is reading it, another is writing inside of it, and they spoil each other. So so that's difficult. So it's much better if you have data which is unchangeable, and when I'm reading something, I know that nothing can destroy it for me. So there's this idea of making new copies. But okay, so if we want to do some local bindings, like basically some shorthands, we want to store something and then use it later in some subsequent computation, there is this let binding, there is a vector, and then there are some symbols. So let x is binded to 4, y is binded to 5, z is binded to 7, or let's do x times y, and we want to sum these things together, and I get 29. So this let allows me to do local binding. So inside of this, the value x is assigned 4, y is assigned 5. I can also use the previous binding, so z is the multiple of x and y. And I will sum them together. So a lot of code in Clojure looks like you do some let, you do some computations, and then you put it together and output the result like this. And most code in Clojure is written with pure functions, which means that you have a function, it has some inputs, and the output only depends on the inputs. There is nothing taken from the side. It doesn't depend on anything else. If you run it again, you will get exactly the same answer. And that's great for testing, and basically these are the basic building blocks which are much more stable and more understandable, and then you compose them together and you build some bigger code. Now, of course, the entire code cannot be stateless. If you would just have pure functions which just output stuff based on the input and nothing would ever change, then we couldn't do programming. For instance, when I run OrgPad, I need to have some state. I need to have somewhere stored what is the state of the document. And when I will change the document, I have to update this state. So there has to be some change over time. Otherwise, the system would be meaningless. And so this is realized. Instead of variables, we use some higher-level primitives, basically inspired from databases. And the simplest one is something called atom. So let me define an atom, which suppose it's a map having 2 keys, like this. And I will call it A. So this def function, this def special form, it allows you to do bindings. Basically, this thing here is now called A inside of this window. Okay, so now I have my atom. If I look at it, it says it's some object Clojure atom with this value. If I want to look inside the atom, I will use the @ symbol in the beginning. So I have @A is, and it gives me the value of the atom. Now, if I want to change what is inside of the atom, I want to update it, there are special functions. There is this function called swap, which takes atom and which takes an input function, which runs on the atom and some input parameters. So like this. Now I have updated what is inside of the atom. So if I deref it again, I get a new value. What is nice about this is that this is completely atomic in the way that the old value is still available. If I do this, that m is at A, okay, I will store the value now. I suppose that I will update it again, that I will do, let's override C with hello. Now if I look at A, it says hello, but I can still recall the original value because I have stored it. It's still available for me. So basically when this allows one to run some parallel computation without any locking, I can just share the atom between threads. And what happens is that some thread, when it goes to read the atom, it will look at the current value and will do some computation with that. It's fine. The state is consistent. When some thread will decide to update the atom, it will run an update function which will take the old state and will produce a new state. And then, when the result is done, it's atomically swapped. So an atom is basically a box which points to some value, and it changes in time. Now, what could happen is that you have 2 threads which try to update the atom at the same time. One is trying to, say one thread is trying to associate C here, and the other thread is trying to associate D here. So what happens is that one of them is going to win, will be faster, and it will update the atom. The other one will come and will take a look at the atom before updating it, and will say, okay, but someone changed it, so I have to restart. So it will start over. And with this system, you can actually build a nice quick shared database in memory. So what we do, that's a quite recent change in OrgPad, that we built our own cache, which is basically a single large atom. It takes about 1 gigabyte in memory. And it contains a lot of basically stuff from database cached immediately, so I can access it from memory and can just output stuff. I don't have to go inside my database. And it was completely trivial with this infrastructure to build it thread safe. So we have tens of threads running on the server, and they are updating and reading from this cache, and everything is perfectly fine. And we don't have to do any locking. We don't have any problems with concurrency. You have if you don't use. So basically, one thing is nowadays computers are using a lot of threads. It was not like that in the past. So we should change the way how we program in the way that it will enable easy sharing of this memory and easy communication. And so using immutable data structures is what one should always use, unless the specific application forces one to use mutations for performance reasons or whatever. Okay, so an example of Clojure. Yeah, we should also look at high-order transformations. So when we do functional programming, what we want to do is maybe we have some sequence of values and we want to transform it, modify it. We have seen already an example, but let's take a look at it more. So we have the range function which generates a sequence. Suppose that I want to update this sequence, that I will increase value of each number by 1. So there's this. So normally we would have to write it like this, like map inc. So map function works that it takes another function and it takes a sequence, and it will apply this function on each element of the sequence, and it will output the result. So what I will get, I will increase the number by 1. Now suppose that we just want even numbers in this. We can run filter function. So filter even. And now if I run this, I just have even numbers from 1 to 10. Okay, now what we can do, we can also sum it together. There is this function called reduce. Reduce takes a function, and it's basically, it will reduce the sequence into a single element in the way that it will take the first 2 elements, it will apply the function on them, then take the result and the next element, apply the function, and so on. It sort of consumes the sequence like this into a single value. So if I use the plus function, it will just sum it together. Now, so reduce basically takes 2 and 4, sums it together, then the result is 6. Then it does, I can actually show you, there's this reductions, this function, and it will, instead of, it will output me the sequence of the values in between. So it starts with 2, the first value, then it will add 4, it's 6, then it will add another 6, it's 12, then it adds 8, you get 20, and then you add 10, and you get 30. So this is the reduce stuff. Now we have a lot of parentheses, and it's sort of difficult to read this code because when you look at this, you have to go to the end, and then you go from inside out. So it's quite difficult to see what's going on. But we don't have to write it in this way. There is this beautiful thing called threading macro. So. And of course, when you work with Lisp, you want to have an IDE which actually works with nicely with brackets, that you can do like basically transformations of these expressions into new expressions nicely with keyboard shortcuts. So I can use this transformation, and this is something called threading macro. So threading macro works as a pipeline. So I have some initial value here, range 10. Yeah, if I run it, I get, yeah, let's put reduce here. I get the same answer as before, but the computation is ordered from top to bottom now. So what happens is that I have the value range 10, this is evaluated, and then it's put inside, so I will put the commas here. So there is this threading macro which puts, so this range 10 is evaluated, is inserted inside this map inc. Then the result is inserted here, and then this result is inserted here. So you can nicely build pipelines like this. There is also another threading macro which puts stuff at the beginning, right after the function name. This is this normal threading macro. So suppose that I start with some map, 1, 2, 3, then I will do assoc b x, y, z. Then I do, say, dissoc a, then assoc c. And so you have a sequence of transformations again. The first value, and then something is added, something is removed, something is added. So we use threading macros a lot, and there are a few other variants. We don't have to go inside, but it's really powerful. There is basically this pipelining system. You know, you have some data, and then you apply one transformation, another, and so on. You go like this, and you will get to some result. Yeah, I think we have probably the language basics done, so we can go back to the presentation. We can finish it, and then I would take a short break, and then we can do the coding of the web application itself. Yeah, so, but if you also would have any question, feel free to stop me at any moment and ask. Yeah, by the way, one thing you might have seen, but I didn't explain fully, is that Clojure is a hosted language. So it runs on top of other languages or other environment. And this is one of the genius ideas that normally when you develop a new language, the problem is that the language is new and nothing is built for it. There are no libraries. So you can't leverage anything which is existing, or at least you can't easily leverage that. And that was also the problem Hickey had, that he built these systems in Lisp and they didn't want it to run it because they had no experience of running common Lisp. And so he built it as a Java library. It's basically just a jar. You put it inside of your project, and people who are running it might have no idea that it's Clojure. They might think it's just Java. So you can sneak it inside production, and in a lot of companies, people wanted to use Clojure, so they sneak it in, and then they started using it. They built some stuff with it, and their colleagues noticed Clojure. They like it, so they started using it more. And over time, they transformed their Java code base into a Clojure code base. And in this case, it can nicely work both ways. So you can basically leverage anything from Java, any library. You can also build a library which can be called from Java. And you can basically inside code any Java code. So the original Clojure runs on top of JVM, Java Virtual Machine, and you have all these great libraries built for JVM. So you have access to your database, and you have your web server, and you have the Java standard library itself, so you can access files, and you can access network and sockets, and you can do all these things out of box. And in a lot of situations, we use Java itself. So there's the JVM version, and later they also built other sort of dialects or variants of Clojure. So one of them I really like is JavaScript version. It's called ClojureScript, and it allows you to target the web. So this OrgPad is written in Clojure backend, and frontend is written in ClojureScript. So it compiles into JavaScript. And Recently, there are also other versions. There is the Clojure Dart, which allows one to target native mobile and desktop applications. So you can leverage Google Dart and Google Flutter, which is quite famous native application environment. There is also this thing, if you like shell scripting, there is Babashka, which is a replacement for Bash. So you can write some small script in Clojure, and you can run it instead of Bash. I personally don't do much scripting, so I didn't have time to play with this, but if you do scripting, it's great. It's really to install, it's fast to start, and so on. So, yeah. My assumption would be that in the future, we will actually have very strong Clojure implementations running everywhere. So no matter what the environment will be, you will just be able to leverage the power of Clojure there. And there are some other, there is Clojure for Python implementation, for R. When you do some scientific computation, a lot of people do it in Clojure. And you have a lot of others which maybe are not that much developed, maybe just one guy is working on it, but if, say, some bigger company would decide that they want to have this, they want to use it in production, they could just fund it, hire a few people, work on it full time, and they could get the full Clojure experience running, and if the community would like it, they can build more stuff on it.
So could Clojure host in the Python?
Yeah.
Do you know any? Could Clojure host in Python?
Yeah, there is some implementation. I am not familiar with it. I have never used it, but I know that some people use it in machine learning because you have a lot of libraries for machine learning and like TensorFlow and these things for Python, so you can leverage it from Clojure as well. But I didn't do it myself, so yeah, I can't say more about that. But there is a big community of people in scientific computing who use Clojure. So you can find some resources on that. Yeah, and so as I was talking, you can use Java or JavaScript directly inside. You just have to learn the notation. So consider the following code in Java. What it does, it creates a window displaying hello world using Java Swing. And it can be rewritten in this Clojure form, which I would consider much more readable and nicer. So actually working with Java is not so bad. Now let's test it out. I have because the previous slides is an image, so I have copied it here. Okay, so let's take this and let's run it. So this is connected to my Java server, so I have JVM, so let's fire it here. Okay, it says, so now IntelliJ is telling me, okay, I don't know what is a JFrame, but you can import it. It knows the Java. So you can connect to its Java library. Okay, I will need to do some imports of Java things. And let's call it F, so we can access it later. Okay, where is it? Ah, here it is. Ah, you can see. So I have my Java window now. Okay, suppose that we want to add something into it. We can do live coding inside of this. Now I'm not a Swing expert. I have never used it for anything. So just show you some basic stuff, but you can sort of experiment and build a small application like that. Suppose that, okay, so I will call this add function on F. So the notation is function name, then the second is the object, which is the JFrame. And then I will do, say, JLabel dot is the same as new JLabel. It's just a different notation. You can also use new JLabel. And let's so add it from REPL. And if we want to show this, we have to call the show function. Sorry, it's not going to work like this. Okay. Show F. Yeah, because Swing is based on mutations. So this is added from REPL. So I can play with my Java stuff here and modify it in any way. And yeah, that's basically it. So yeah, I don't know Swing that much, but at least I wanted to show this thing. By the way, the values we have seen, so if I have what is type of number 42, it's Java long. It's basically just Java long. If I have my hello string, it's just Java string. So there are no wrappers. You can just use the native types. If I go to the browser, to the other REPL which is connected to the browser, and I do type of 42, it's an object number. Now I'm in JavaScript world. If I do hello, it's object string. And there is different notation if I want to access some Java stuff, say console, say alert we have seen, and there is a prefix JS. And it will do an alert for me. Yeah, so I can basically leverage anything from these platforms, and this is what we do. And basically, what you see, the application OrgPad is written in React, for instance, which is the most famous JavaScript framework for front-end stuff. Sure. Okay, so. Yeah, if we go back to Clojure, there is one more idea I want to present, and we will have break. And it's this thing called data-oriented programming, which I absolutely love. And that's the idea, okay, the data is the most important and the most understandable thing in your code. And for instance, let's consider the example of internet, which is the most scalable thing which was ever produced. If you like, internet started really small and it grew to these huge sizes, and it was able to do it iteratively. It was able to improve, add new stuff, and grow, and people could easily start their own web server and serve some stuff, and so on. It works like this. Internet runs on plain text messages. It's just a data, easy data. So you have formats like HTTP, or another format which is really famous now is JSON. JSON sort of looks like the stuff I was showing you in Clojure. There you have vectors, you have maps, you have the readable data. Like the Clojure stuff is a little bit improved JSON. And one of the reasons is that doing programming in JSON would be bad. Like it's not nice language for programming, for these commas, and you have strings, and you can do really nice programming in JSON, but you can do it in Clojure or Eden in this case. On the other hand, there are some binary formats used in the world, like object relation mapping and stuff like that, and they're really bad ideas, and they don't really scale. They are not readable unless you have the code. You can access it. If I send you a binary file and I don't tell you what these things mean, you can't read it. Only I can access it if I know code, or if you will decode it, of course. But it's a lot of work if you have to decode some binary format. You don't know what it does. So yeah, it's not so great. And the main idea of Clojure is, okay, internet is built on these plain text messages, and it's great. It scales. You can easily add more stuff. You can improve. So why should we build the interiors of our systems differently? We shouldn't. We should also send a lot of plain text messages or a lot of plain data. So normally what happens is that in Clojure you store the data just as data. The modules are exchanging the data. They send maps and vectors in between, and it's much more readable. If you want to understand what's going on, you can just print it. You can send it over wire. You can store it. That's super easy. So basically the idea is try to use and leverage data everywhere where it's possible. And actually there is this super nice book by my friend who basically took these ideas from Clojure, this functional data stuff, and it's great about the book that it actually doesn't require Clojure at all. He explains these ideas fully with JavaScript. So then these ideas are accessible also to other programmers outside of Lisp and functional world. By the way, beforehand I was also showing this this interactive example. This is also something he wrote. This is his open source project called Clips. It allows one to run inside browser computations here for Clojure, but it also allows to run JavaScript and other languages. So it's quite nice. Yeah, so I can recommend this book. So some talks. Yeah, so this is an example of data we prefer in Clojure, and we can play with them and see what's going on. And this is actually something which was generated for me by ChatGPT. It's just like, give me some books, and he gave me this, and I say, okay, but let's improve this a little bit. So it knows Clojure as well. That's nice.
Just like it's a database, but a little like a database.
Yeah, and databases are great also because it's just your tables. You can read them, you can play with them, you can use it in different languages. They are understandable. So you can take a lot of these ideas from databases, and you can just sort of put them inside of your code as well.
Yeah.
Why should you wrap everything in some object and in some box and close it and don't understand what's going on? If it's a string inside, you still have to use it as a string anyway in the end. Okay, so suppose that I have this. So I have some values. Let me run it in the server. So I have my books, and I can do some transformations with them. For instance, I can sort them by year. It's quite easy. So I will do just sort by books, and format is, there is a key function. So let's do year, sort them by year. Yeah, by the way, keywords are working as functions. So if I use keyword, it will just get itself from a map. So if I have this keyword A, works as a function, and it will takes itself from a map. So then I can use it inside of map function, inside of sort function, filter function, whatever. So for instance, if I would just want to see the years, the titles, I can just use title as a function. Nice, concise like that. Okay, suppose that we want to know how many authors are there. We can just group by. The same stuff you know from SQL. So you do group by, author, books. And I get a map whose keys are the authors, and the values are sequences of the original values.
Why embedding this data?
Sorry?
Embedding this data. So just like call OpenAI's API and
I mean, you could access OpenAI, or you could or you could just have some database, some data somewhere in say in the memory or in your database, and you want to play with them and see what's inside. Yeah, in this case, I just basically copied a fixed list, and now I'm playing with it. But you can, of course, access the data from all possible sources, and you can easily parse XML and CSV and JSON and whatever.
Yeah.
So yeah, it's like if you do any data stuff, then Clojure is great. It's built around it.
Okay, I think so.
Yeah. Okay, suppose that we want to do a map from author to the titles of the books. Sure. So let me transform it like this. So first we did group by, and next we do map, which takes a function. This is an anonymous function with the author, and then books for this author. I will output author as the first parameter in the vector, and then I will do map title on books. And I get it like this. Now, I wanted to have a map instead of a sequence of pairs, so I will call another function into which will take this and build it inside a new map. And I have a map like this. And I can ask, for instance, okay, get me books by George Orwell. And I get these two, 1984 and Animal Farm. So I can do transformations like this. Yeah, one thing I haven't shown you yet is we can actually do, we can put this data inside of our application somewhere, inside of our server. Okay, so suppose that, so my server runs on localhost 3000. Okay, suppose that I want to do, let's do test. Okay, test, I get an error because test is not a route we have on the server. And ugly stack trace, but like when you want to read this, you can actually figure out quite quickly where the problem is. Now we don't know what is the test. So normally if I would do the classical coding, I would have to do some coding, then I would have to stop the server, I would have to compile my code, and I would have to run the server again, then I would figure out, okay, it doesn't work well, or I made some mistake, and I will have to repeat this cycle. And it's painless. I don't have to do this because I have REPL, so I can modify the code while it's running. So first, what we have to do, we have to add this route. So we have to tell the server, okay, if you find test, you will do something. So let's add test inside of routes. So for that, we have this routes file. This file, by the way, is actually, it's in the CLJ-C, so it can be shared between front-end and back-end. So we can write code which runs both in Java and in JavaScript, and we can share it. So in my client, I generate URLs, and I use the same routes, the same addresses as I use on the backend. So if I decide that I want to rename something, I have just one place where I have to change it, and everything updates accordingly. So this power of Clojure allows me to share a lot of code between front-end and backend. Let's add it somewhere. So let's do, okay, test, and this will correspond to up test. So this is just a mapping of names. So I just map the address to some keyword, some unique identifier. Let's reload it. Okay, it's now loaded on the server, but it doesn't do anything because I have just added the address, but I haven't said what it does. So the server doesn't know yet. Okay, so let's do the modification. So let's, so we usually store it here in the handler. So let's make a new file for it, test. Yeah, and okay. So I will write a handler which take a request and will just print me okay, hello world. And sure, I can reload it, I can add it to the project, now it's there. Now I can call it orgpad.server.handler/handler. I will get the output map. This is the response map, which will be used by the server to send the stuff out. Sure, but still, it doesn't work because I haven't connected it yet. I haven't said, okay, if you encounter this test route, you have to go and call this function. So I have to add it somewhere. So I go to the core namespace. And here there is this mapping from the keywords to the functions. So let me just add it here. So up test is I use this this notation. This just means that the function is always lookup. If I change it while it's running, the server will use the latest version of the function. Okay, I have to also require this namespace. Okay, now it's working fine. So now I have to reload it. And now the server is sort of like restarted. This server module is restarted. That's happened. Now if I go to test, okay, the test file is downloaded because I haven't specified what is the format of it. So browser doesn't know what is the format, it just downloads a file. Let's do that. Okay, so normally what we do is we chain it like this. So we do response content type, it takes the response and it will output, let's do text plain. If I run it now, there are also some headers. It says that it's in the plain text format. So now the browser will display it. Now I have everything set up and I can put some meaningful content. Okay, so there is this input, this request map. Let's print it out. Instead of hello world. So I can use this function which will basically nicely format me the output. So if I print it now, it will, okay, output nil, but this is not a real input. It might look like this. So this is the input. You see the headers, for instance, what is my machine, what is the address I used, and so on. Or the format comes here, like this, in a text format. And I can, for instance, if I put some parameter here, you can see it here. Yeah. So it just updates. Okay. Okay, suppose that we want to bring our books inside. Suppose that we want to I would just copy it here. And suppose that we want to print what we did before. So maybe we want to print, say, the names of all the titles. Map title, books, and let's join it together by a new line. Here's this. Okay, I will reload it. I have my books. I can nicely play with the data. I can develop the server live like this. And this, just to remind it, this is running a huge project. The server is about 20,000 lines of quite dense code, doing a lot of stuff, and I can still like modify it on the fly. And what I can actually do, I could connect to the production server, which runs in Frankfurt in the data center, and I could modify it in the same way. So I could just do the same stuff, and I can access the live data in production, and I can do all these amazing things. So it's a super powerful weapon tool, but also you can blow your server up if you do some stupid stuff. So you have to be a little bit careful if you access production environment. Because like, we don't want to lose the data for our people, and we also don't want to, like, for instance, overload the server that it wouldn't be able to handle the traffic. I could run some expensive computation, take all the threads, and then the server would be dead. So yeah, it's a powerful tool, but like you have to be careful to not shoot yourself. But it's also incredibly valuable. Yeah, suppose that we want to do some HTML. So what we do normally in Clojure is that we don't, the HTML itself is quite bad because it's a complicated string. It's really difficult to parse it, and it's really difficult to transform it, work with it. So we write HTML in a different notation. We use something called Hiccup notation. So if I want to do, say, a div, I will do a vector which has a keyword, the tag. Then there are optional parameters, and then there are the children, the remaining things. So I have this div ahoy, hello in Czech. I can make it bold. I can wrap it with the b tag. So this is these nested vectors describe HTML. And this is called Hiccup notation because the original library who introduced this is called Hiccup. So I can call Hiccup HTML and I can convert this into a string. In this case, this is something called raw string, but I can just convert it into a normal string, and I get the HTML you know. Yeah, I can also add some parameter, and it will be converted into HTML parameter. So I can basically build my HTML as a big data structure, and in the end I will do the last transformation. I will use the Hiccup library. So suppose that we want to build a nice list of book authors. So what we can do is, so first the format will be text HTML, and so it will work like this. So let's build this. Okay, so how we do it? So we have our books. First we do group by the author, like this. And now we want to produce a nested list. Okay, so I might do a map like this, which takes the author and takes in books, and the output will be li as the element in the list with the author name, and then another nested list inside for all books. Okay, suppose that I will just put book here. Let's test this out. So what I get is this li element, and there is ul, and then I have a sequence. I have to build an inner list for it. So what we do normally is we do li and then say title. This already starts to look like an HTML, sort of. We need to add ul on top of it. So maybe like this. No, let's test it out. Okay. Maybe I cannot use a Hiccup here. Yeah. I have my list of books as HTML. Suppose that I want to add here. So what we normally do is we do this destructuring here, which allows us to quickly capture the values from a map. So let's do title and year. And let's suppose that we want to add a title, and then we want to add year in brackets like this. Yeah, normally what you do is you don't copy it here, but you write it directly in the editor, and then you just reload the file. So we do it like this. Okay. We have the here. Suppose that we want to sort this. So what we do is we can do sort by year. And you can play with the data like this. So data is amazing. Yeah, we should use them basically everywhere. So we have the Hiccup notation. We can describe HTML. This is how we generate HTML on the front end. We generate Hiccup, then use the standard libraries to convert it into HTML. Yeah, this is an example of this is a React component, actually. Basically something which looks like this: that you have a counter, and when you click on it, it updates. There is the beer increment, something very useful when you're visiting Prague. Okay, so is this. So object-oriented programming, on the other hand, is something I don't really like that much, because the idea is like you hide the complexity under the carpet and you think you solved everything, and a lot of situations you didn't. You actually make things more complicated by hiding it. Actually, the inventor of object-oriented programming itself hates the term objects, that it was a mistake, because people concentrated on the less important idea. The more important idea was messaging. So when Alan Kay invented Smalltalk, it was inspired by a biological system where you have some entities, then they communicate by messages. And it was a sort of living system where you were programming inside of a living system. So something we have here is in a lot of ways similar to the ideas in Smalltalk. Also like super old history of programming, it's from 70s. So I found this on Twitter somewhere in animation sort of illustrating object-oriented programming. I gave these, like first of all, this is a mess, like these entities and they somehow move and interact and so on. Yeah, it's also wrong, because this is not object-oriented programming, because you don't have entities actually. Objects are more like this. They're like marionettes, like these puppets you control. Because when you hold a reference to an object, you can do anything with it. So basically nothing in the real world works like this. It's like if I suppose I want to turn off lights in this room and I don't know how to do it. Say I will call my friend and say, can you switch the light off? I will not grab his hand and move it towards the light switch. I will send a message. He will interpret the message, will decide like, okay, I will do it, or screw you, I don't want to go there, I'm too lazy. That's perfectly fine. The other person can decide what they want to do. You send them a message and they will reject communication with you. They might block you, or they might send you something back, and you do interaction back and forth. And this is how the real world works. Also, there is nothing like locking in the real world. Like suppose you go to a football match and you want to take a picture. It's not like you will stop the world as a Neo from Matrix and will say, okay, everyone freeze here because I want to take a picture, I want to look at something. No, you just take the picture. The physics, like you have the photons which reflect from everything, and you take picture by capturing the photons. What was there? But the world is still moving forward. It doesn't stop because you don't have the superpower to stop everything. So we have to stop programming in the way that we think we have the superpower to stop everything. There are large systems with a lot of processors, a lot of computation going on, maybe on multiple machines, and they communicate with each other, and we have to live in this world, and we have to be effective. So the HTTP request I was talking about, this is just this text. It has some headers. The header is some keyword which people agreed on, and then some value, and then there is some payload below. It's a text message. You can read it, you can understand it quickly. In Clojure, we just represent it as a map. It's not that complicated. In the Java world, it's just some messy object like this, with some ad hoc language. Something you wrap like that, something differently, you have to learn the language, and so on. So data is much simpler, because this is everything. You don't have to have any extra understanding. You have this data, and you can write some functions which transform it and read it and do something about it. So I just want to show you a quick sample from one talk by Rich Hickey. He's, by the way, an amazing speaker. I really recommend some of his talk. Like simple made easy is legendary. So let's play this.
So one of the other things I think we suffer from in object orientation is death by specificity, right? All the time. We have a new thing, we have a new idea, a new piece of data, boom, we have a new class. Get this, get that, get whatever. I don't care if they're value types, whatever, right? It's just a glorified map, except you can't even use it as a map in Java. Right? There's no generic way to manipulate something that says get this, get that, get that. It's a new type, new language, it's got its own little vocabulary. Right? So you're going to have more code. You're going to have much less reuse. You're going to have more coupling. Right? Because essentially what's happening is every object has its own little language. My class, my interface, my own language. This is my biggest pet peeve. I wanted to get away from this. When we started writing get this, get that, it's like there's no purpose to this. This is just life-sucking. So let's look at life-sucking. This is just a tiny part. I actually skipped, this is just the servlet request, and I have a little bit of HTTP servlet request, which really doubles the size of this thing. But my question to you is, how many maps do you see here? We're like, give a name, you get a value. I got one. I actually can't do the auctioneer thing. How many you got?
It looks like there's one or two submaps, like parameter names, parameter values.
Yeah. All right, so first of all, this game is hard, right? There's some. I got 3 inside, and the overall thing is a map too. So I got 4 right off by picking it apart. What's really interesting is, look at these map interfaces. They're all ad hoc. Guess what else? They're all different. One has setting, one you can actually get the map, one you can get a list, some you can get out with types. There's 4 different maps in this one class. This is crazy. Right? In Clojure, we just use maps. Right? This stuff came over wire in HTTP as text. How did we turn it into this? What happened? What happened? Why, this is crazy. Now, who can, I told you the curly braces are maps. Who can see how many maps? 1, 2, you see all the maps. Because there's still maps, right? If you're gonna write code that manipulates that other stuff, every single line of code you write is gonna be special. Has to, use whatever, Java X servlet blah, right? And you're writing code explicitly to this thing. If there's another way to do HTTP, not that there is, servlets are probably the only way to do HTTP, but if there was another way to do HTTP, will you be able to reuse that code? No. It's all written, it's all hardwired to this person or person's idea of like what an HTTP request is, right? So yeah, okay, there's a tiny little benefit, right? Dot works in your IDE, woo! Oh my goodness, because I could never remember that. So I bet something better happen when I press dot, because I'm doomed otherwise. Of course, I could look at the HTTP spec and like we could agree on these names, and I just don't get it. You can tell a kid not to put a spoon in a blender and turn it on. And like they will remember that for their entire lives. They will never make that mistake. But grown-up adult programmers, like we need protection, right? From this stuff. But the protection we get is really minimal. What's the cost? It's huge, right? That's an inconsistent interface. It's incredibly idiosyncratic. The interface is huge, so if you wanted to like have a second implementation, get to work, right? There's a ton more code to consume it. You can't use any of the libraries you already have, right? With the Clojure version, all the map code, like I said, those hundreds of functions, they work on this. You can create this with them. You can read this with them. You can merge 2 of these with that. And you have no new code to manipulate this, no new code. All the functions you already know manipulate HTTP requests. as soon as you represent them as data, which they were, by the way, before we mapped them, right? The testing, right? It's easier to test data. Can you make a program that makes this? Yeah, can you make a program that makes one of these? Yeah. Okay, and the other problem is your typical Java program has 2 to 3 orders of magnitude more of that. More of this, right? 100 classes, a couple of hundred. How many people have programs with more than 1,000 classes? Yeah, that's a party. All right.
Yeah, so I think he summarizes it nicely. Yeah, I can really recommend the talks by this guy. By the way, if I would go back to my history originally, I was sort of tired of programming because I was doing it since I was 6, and after some time it's just everything was like the same stuff over and over, and you spent like half an hour doing something interesting, and then you spend 2 weeks just writing some nonsense code you have to write because object-oriented programming stuff, whatever. And so at the university I decided to pursue theoretical math. So I did theoretical computer science, like algorithms, designing algorithms, and connecting it with mathematics and these things. And yeah, I was sort of bored of programming, but then I discovered Clojure and basically the ideas Hickey bring to the table, and I found that actually you can solve these problems. The programming doesn't have to be boring and slow, and you don't have to type a lot of stuff and get almost nothing. And so I started working in Clojure, and I loved it. And also in OrgPad I have a project which I actually need to code. So it was another very strong motivation. Yeah, so we have some, I think we can skip that, but there are some clever ways how to do these immutable data structures using trees. So everything is stored in memory as a tree, and the idea is if I want to update a part of the tree, I can just update a few nodes in the tree, and the rest can be shared because it's the same. So you might have a tree with big branching factor, like you have a terabyte in memory, and it might just have depth, I don't know, 7. So it's a shallow tree, and when I update this, when I add inside of this terabyte hash map something, I will just update 7 nodes. So it's super cheap, super nice. So you can do these things, and Hickey spent a lot of time to make them as efficient as possible. Yeah, by the way, functional programming is something which is becoming more and more like mainstream. I think pretty much every programming language nowadays has some functional stuff, like this functional transformations, map, reduce, filter. It's everywhere, even in C++, where it's super ugly, but it's like they decided they have to add it as well. Yeah, I don't really like the name functional programming because it describes the stuff as something mysterious. Like when I first saw it, I could imagine like functions from your calculus class. Like I'm going to program with sine and cosine and do what? Like it doesn't make any sense. I think it again focuses on the lesser idea. The more important idea are the data. Then you do transformations. You change the data over time. Functions are not that important as data. And by the way, there's this thing called Haskell, which I absolutely hate. Because my experience from my university studies is that we had a Haskell, and like when you go to university and you take Java, at the end of the semester, you know how to build a simple application in Java. You can build some small game, or you can build small web server, or you can write some useful stuff for you. When you take Haskell, you just learn how to do some computations with numbers, and it doesn't make any sense. It's just so split away from the real world. They have like this category theory stuff and monads, and they never are able to explain what are monads because it's like so complicated. You have to take a few years of algebra to understand what's going on, and there's this mystique. And I know a lot of students who absolutely hate functional programming because they imagine Haskell, they didn't understand anything, and it really gives them pain. So I actually put this funny picture here. And it basically gives them this feeling that, like, screw this, I hate functional programming. I never touch anything functional because of they had a bad experience in the university. So Clojure is practical programming language. You can build stuff fast, easily, much better than in the other languages, and you can really, like, most of the time I'm just concentrating on my product. I care about what functions I'm adding, I'm improving stuff, making it faster. I don't care about language that much. That's great. So we want to build a small web application live with Clojure script here. And so we will be leveraging React, which is the most famous JavaScript framework for building web applications. Which is designed by Facebook, and it's really, like, used in a lot of situations. There's a lot of libraries, components built for React, so it's great. We can actually make React better by wrapping it nicely in Clojure. So there's this Clojure library called Reagent, which wraps React and makes it more functional. And also in a lot of situations faster. So when basically Clojure script made React faster, so they had to rewrite React to leverage immutable data structures, because they figured out that immutable data structures make things faster. And then there is this another Clojure library, which most familiar to use. It's maybe a little bit overkill for this small application, but it's Re-frame. It's basically a way how to structure your application into 4 different pieces which communicate with each other. Okay, so this is Reagent. We just write these Hiccup components and they render as HTML. You will see that. Concerning Re-frame, the application is built using this cycle. First, we have some state, which is just a deep nested Clojure map, which describes basically everything what is displayed in your application. So if you want to see what is displayed, you can imagine that it's a sort of a function. I have some state, and I build some function which will generate HTML out of the state. When I update the state, I could think of React as completely like regenerating everything. Like remove everything and start over. Just generate it from the scratch. And of course, this would be too slow, so they do it in a clever way where only the parts which is updated has to be recomputed. So yeah, I have some component like this, and in this case it's static. It doesn't depend on anything, but it could depend, and there are some events. So suppose user clicks on a button, or I'm receiving a message from the server, or something else. Yeah. So these events will be dispatched, and they will take the state and will transform it into a new state. So they will produce an updated state. So the state is an atom. It's a single atom, and it's just there is a sequence of updates. So it's changing over time. And then there are these subscriptions, which are basically sort of cached values. So the idea is, like, I do some computation from the state, I derive some new stuff from the state. Maybe I just need to display some part of the state, so I will just derive this part, and it's cached. So this is just to speed things up. So I have I have my state. From this, there are some subscriptions which compute something. From these subscriptions, maybe there are some subsequent subscriptions which compute something. And then these subscriptions are used in some components to display stuff on the screen. Now, when the state is updated, like this, so I have a new state. I have to recompute what changed. So I will recompute this subscription, I have a new value. I will recompute this subscription, it's orange because the value is the same. So this one is also the same. What it means is that things which only depend on these orange values, which are not changed, don't have to be recomputed, because they would be the same. So I'm saving time, I'm not recomputing these things. I know that they are the same. But I have to recompute this is again different, so I have to update this component, I have to redraw it, and I have to redraw this component. So this is some clever way to make things faster. Okay, so we have this cycle, so let's go build it. Yeah, by the way, so you have seen OrgPad. I will now show you how to use OrgPad other than for presentation. But if you're interested, you can test it out. It's for free to try it out, and you can use this promo code to get a discount. So if you're interested, then you can help us by supporting our work, and we can make it even better. Okay, so if we want to, so I want to build tic-tac-toe 3x3. So I think the best place to start is to design the state. Oh, let's see. Okay. So I want to design the state. Okay, so what should be the state for tic-tac-toe? So there are a few things I need to remember. The playing field. Field 3x3. I need to know where are the crosses and the circles. I should remember who is playing now. And maybe I should remember whether someone won. If someone won, I want to display a congratulations, player 1 wins. So we have these things. Subscriptions will be super simple. We don't need to spend much time with that. And components, so one of them will be rendering of one of the fields. So it will render the correct symbol. And I need to render the entire board. I need maybe to render some button. Yeah, so I have a field, then I have a board, like this, then I have maybe some reset button, win message, and so on. And the events will be like things like user clicked on the reset button, so erase everything. It will be click on a field, okay, by a turn. So let's go to build this. Okay, so I have put it like this. So this is an example project I built. So I have some CSS, which I can write CSS also in Clojure. This is a library called Garden. So I have this body. Let's build something really ugly. Color red. So let's I have this thing here, so this is running. This is reloading immediately. That's another magic of Clojure. So if I put here blue and I save it, it gets recompiled immediately. I'm not losing state. It is not reloading the browser. It's injecting inside of running application in browser. So I can build CSS like this. But where we should start, we should probably, so this is a simple application. It has a view which, this main panel, which will basically display, it will take the name from the subscript, it will take the name value from the state. So the state is just this name here. So if I update it, now it's not recomputed because the state is not changed. I have to reload it, but now it's changing. But if I go here to if I modify it, you can see that it's immediately updating. So I can do live coding like this. Okay, let's remove this stuff here. So we can start by building some example state. I think it's the best way how to do it is to, let's build some state, which maybe continues a few turns by it. Then we can do the rendering for it. Then we can start to add these events, and in the end we will have the full game. So what should be this? So we have fields, board maybe, let's call it board. So how should we store it in memory? So if we would be using some classical languages, it would be a two-dimensional array. But two-dimensional arrays are, first of all, quite slow because immutable two-dimensional arrays, it's a lot of work, and also updating them is not so easy, not so nice. So I would recommend not using two-dimensional arrays. I would just recommend using a hash map. So we will have a hash map where the keys will be the coordinates of moves. So let's say the position 0, 0, I will have some move. So let's say player 1. At position 1, 2, we will have player 2, and at position 0, 1, we will have player 1 again. So this might be the state after 3 turns, like this. If another turn is done, I will just associate another value inside of this map, and so on and so on. Maybe I have current player is player 2. Let's start with something like this. So we will reload the application. I have some error. No. Yeah, as you can see now, the name is nil, so it's gone. I don't have it anymore. But let's tear this down. So we have it like this, just a hello world. There are the subscriptions, so there's this syntax which takes from the DB and computes me some value. So maybe let's do a field. Let's do board subscription, which will take me the board value. So I can print it like this. rf subscribe board. And as you can see, I have, yeah, I should probably make it bigger. Maybe let's do the styling afterwards. But as you can see, I have, I can read parts of the state and I can display them somehow. So let's do the main rendering. So what we need to do a single field which has some positions. So it's X and Y. And we need to know what is the value of this field. So let's do rf register subscription field. And this subscription will take it will depend on board. And it will take some input parameters X and Y. And it will just do get XY in board. So it will return me the value for the particular field. This subscription takes as input X and Y. Okay, so we do div here, and let's say rf subscribe field X and Y. Let's do it like this. Okay, main panel, let's call it, let's do another component called board. which will do for all x from all y from 0 to 2, from or x from 0 to 2. We will do field x and y. Does it work? A compilation error. Macro expansion. Yeah, because I forgot the parameters. Okay. We have 0, 0, 1, 0, 2. That's a bit strange. Let's see what's going on here. So I have my strings here. Okay. Maybe. Yeah, I haven't actually used because it should be like this. In OrgPad we have REPL wrapped a little bit, so we use it differently. Okay, expected field. So yeah, it should be like this, I think. Okay, let's use the different form. I don't want to. Okay. So okay, now we have 0, 1, 1, 0, 2, 0, 0, 1, and so on. Okay. Can take a look at documentation. I have some example code. NDB. Query. Now I don't see where is the problem. You see it? Ah, now it works. So there's something wrong with the for cycle. Maybe no. Ah, I see, because, oh yeah, sure, okay. Yeah, I cannot have a sequence, I have to wrap it in something. Yeah. Okay, yeah, let's move on. So now we have this thing done. So the output now is, it consists of, okay, 9 divs, sorry, where the name of the player who played it, but it's not displayed as a board yet. So we should fix that, and we should also probably do some map from, like, we don't want to display player 1 and player 2, we want to display X and circle. So let's say player 1 is X and player 2 is O. And we want to, I don't want to have it here. Okay, what we want to do, we want to display axes and circles. Okay, so how should we go around it? So we do div board and div field. What happens is that this just adds HTML classes. Notation to add HTML classes, so we can do some CSS. Now, it's possible to do CSS directly here. For instance, I could say color red. Does it work? Now I need to wrap it again. I have to say style color red. Now I do styling. I could write inline CSS here. Usually I prefer to write it in a separate CSS file, which I have here. So what should be so first we have board, and we want to display board as a grid. So let's do grid template columns is one furrow, and one furrow. So I have 3 columns of the same weight, and grid template rows, I have 3 rows of the same size. And now I have already something. Let's add let's add a border around. Sure, so now I have something. Maybe let's add some padding. Let's do, I don't know, 4 pixels, whatever. Margin, sorry, not padding. Like this. Okay, let's do the board. Let's put it. Let's do it 100 by 100. Okay. How is it? Align self. And justify self. I think. Okay. Now we. Can we do it like this? CSS is, yeah. Okay, we have something. No, it doesn't. Probably don't even need border. I don't want to spend too much time with CSS here. Um, no, so let's go with this. Can maybe do some background color. Yeah. Sorry?
It might be place it at center just in the board one liner, and it should center everything inside.
Like this?
Yes.
Yeah, but I would, yeah, I mean, can also, like, I can center it like this. I think, no, doesn't matter. I don't want to spend my time with CSS. Yeah, this is absolute abomination of anything. Like, yeah, I'm using CSS for several years, and it's still like sort of ad hoc stuff, and that's not really that important for this talk anyway. Okay, so let's go with this. Okay, what we could also do is colors. Let's do player 1 is like red and like whatever. Background color is color of now let's extract this. And okay, some nice blue color maybe. I don't know. Whatever. Let's find something. Okay, so now we have this, but it doesn't do anything. It's just a static thing. I can click it. I can modify anything, and just renders some HTML. So let's add some behavior to this. Okay, so let's do on-click event when value is nothing, so the field can be played. Let's do ref dispatch some event field x and y. So I have a click here. Now, okay, does this work? Test it out. It's reporting me, okay, I dispatch an event field, but I don't know what field is. So you should define a field. So let's go to events. We haven't done anything yet here. So let's register event field. This event will take the DB, the current state of the system, and then it will take two values x and y, and it will add a turn for the current player. So we have to maybe extract the current player. So we can do it like this. Now if you recall, the current player is stored under the key current player. And so what we will do? We will do two things. We will associate in DB underpath board xy the current player, and then we will store if current player is player 1, we will store player 2 is now on the turn, otherwise player 1 is playing. Let's save it, and we can build it like this. Now we can play, except yeah, there is no checking whether someone won. We have to add this, and also now we are stuck. We have to reload the application, and we can play again. Yeah. Have you found some color which looks?
Sky blue. It's
Yeah. Okay. Let's.
give it as.
No, it doesn't matter. Yeah. Okay, so yeah, this looks a little bit better, I would say. Okay, so now let's add the reset button, so we can actually reset without reloading the browser. It will be also easy. So let's do it like this. Let's do a new component called reset, which just renders a div class reset with text reset. We will do some styling of that, hopefully. And on click, we will dispatch an event called reset. Yeah, it again complains it doesn't exist. So let's add it. Let's do ref register event db reset, and what it does, it will take db and it will let's just ignore db completely. Let's just build a new map. So we can do, so current player will be player 1 and board will be nothing. Or maybe we can just add empty map. Okay. Well, I can play. Almost there. We still have 10 minutes, so we can probably finish that. But basically, what is really nice about this development is this is in the community called the hot code reloading. Is you have your state of the application. I can change the code. I don't have to reload the window. I don't lose the state. So I can just play with the state. I can update it. I can do something. I can check it in REPL, and I have much more instant loop. And having a quick feedback loop is amazing when you do programming. People often say that you should iterate fast. I think iteration is a really bad word, because iterating meaning starting over. You don't start over, you improve. So you start with something, some quick experiment, and you improve it. You build it, make it better. As we play here with the tic-tac-toes, we don't remove everything all the time. We improve. In the end, we get something which is good. And it's also a lot of fun to do it in this way. Basically, after like getting used to this experience, it's really, I think it's impossible to go back. It's like when you encounter like, I don't have this system, you built it because you want to have something like this. Okay, so maybe we can do some CSS. Let's do reset. Okay, let's do background color. Let's do sky blue. That doesn't look so bad. And maybe let's do padding, I don't know, 5 pixels. Who cares? Yeah. And I have to click here. So let's do game. Let's do flags for the game, and let's start the game. How's it? Okay, one more try. This is justify items. Start. Nah, I don't want to do CSS. Let's do some more fun stuff here. Okay, so basically the last two things we should do is we should check whether someone won, and we should display, okay, congratulations to player 1 or player 2. Sure, so let's, how should we check whether someone won? So in 3x3 tic-tac-toe, it's either entire line is taken by someone, or entire column is taken by someone, or one or the other diagonal are taken by someone. And there is a lot of different ways how one could code it. I could just like write all these conditions as I describe. I can write some function. Let's write some helper functions. Okay, so how do we do it? Let's do a row in the input is a board and row number y, and I will return the name of the player who takes the entire row, or now when no such player happens. Okay, so how we can do it? We can write it, for instance, get from board 0y. So we have to check that all these values are the same. And now it would return also true, yeah, if we can actually let's do it like this, and now it will return true because the entire row was filled by zeros. It's before the adding the cross. So I also have to check that at least one of them is non-zero, non-nil. So I get this. Now it's not winning. Not winning yet, but now it's winning the first row because I have to do it afterwards. Okay, so let's do an updated board. So let's do board let's store the current player under X and Y in the updated board. And let's do this for the updated board. Okay, let's and player. I have typo here. Okay, like this. No, this. Okay, let's do this, this. And now you can see that I'm already winning in the first row. Fine. So now, yeah, and this code is definitely the simplest one. But we can do the same for the column. And then we can do the diagonal stuff. Let's write it as a single function. So the center has to be taken by someone. And then either all these values are the same, or all these values are the same. So now I have rogue functions, common functions, and diagonal function. And so we can write that someone won when or row 0. There is a question mark. It means that it tests something. Row port 1 or row port 2. Okay, let's print it out and let's see. Let's reset. So 1 now. Okay, let's see now. And now, yeah, it's still now. Let's see, so diagonal. Doesn't. Probably some typo somewhere. So it's false now. Why is it false? 2, 0, 1. Let's print board here. It's true. Ah, yeah, because I'm calling it on the. Doesn't solve. I'm calling it on the. Yeah, and now it should be 1. Okay, so let's display it now. Okay, so let's add another piece into the state whether someone won. Okay, if someone won, we don't do anything. And now there is this thing called cont, which allows me to add conditions. And part in the pipeline is executed only when condition is correct, so these are executed always. Or we could also, let's just not do that. Let's just assoc 1 as 1. Okay. Let's reset. Can play anymore? No. I have to press it correctly. Okay. I see. It would be 1. Yeah, I just overrode the value. Let's do reset. New one. Yeah. Yeah, and now I can't play anymore because someone won, but I should also display it. Okay, so let's display it. Let's add a subscription. One. Okay, like this. And let's render something. Let's do state fn state. Let one ref subscribe one. Okay, one. When one, we will just display, I don't know, div. Congratulation and name of the player. Name function will return a string from a keyword. Okay. Now I'm getting an React error. Doesn't support one on true. Oh, I see. Okay, I have to. New one is current player. Let's do it like this. Okay, let's see. Okay, reset. Okay, this is certainly not correct. Yeah, congratulations, player run. I can clean it a little bit. Reloading is sort of working that well today. Sure, and we could add some nicer look to it and play with it further. Maybe let's make it 5 by 5 or arbitrary size and 5 length and so on. Yeah. Also, you can certainly write this way better. For instance, there is a lot of stuff repeated here. This, for instance, this here, we can write it in the way that we will say every row 0, 1, 2. Write this as a function. So we can basically we can cut these 3 lines by using every predicate. Every runs on a sequence, tests the function, and it not every, some, sorry. Some runs is the opposite, it's any, basically. Yeah, we can do also the same stuff here. So we can clean it like this. We can test it out. Congratulations, players won. So this is already quite simple, this code. And concerning this code, we could write these things better. For instance, this. Suppose that we want to simplify this. So we can do map on 0, 1, 2. Function is get board percentage, and percentage is the name of the argument, and so x and percentage. And if we want to compare all these values, we can use apply equal, which will basically put the sequence inside of equal function. So it will build equal and return values for this. Okay, let's do the same stuff down here. Sorry, this is for column. X and yeah, column, yeah, it works. Now here it would be just this. Now you could unify it even more. For instance, you would have a parameter which would be the direction, and then once you would pass 0, 1, and once 1, 0, and you get direction like this. And you can play with it further and further, and you can get something.
You can always improve it.
Yeah, you can. That's the fun of thing, and you build stuff, you play around, you make it better, and you learn about it this way. Yeah, so I think we can probably stop here. Hopefully have some idea. If I just recall very quickly, I think one cool idea is always try to use data. They're transparent, they're better to work with. Try to make your coding environment as interactive as possible, because if you can make the feedback loop faster, you will do more improvements. You will make your software better if you can just quickly test things out. If your iteration cycle is 5 seconds or 5 minutes, is really bad. If it's 1 day, it's even worse. You will almost not try anything. And you have all of this context switching and stuff like that. So, yeah, and there is also this data-oriented programming book I can recommend. And Rich Hickey and his talks. Yeah, you can just basically find. You can just open this link here, ECC Edu, and get there everything. And the talk was also recorded, so we will publish a video and make it available for you.